Okay, what I'd like to do is talk to you now about the nomenclature for covalent non-ionic compounds, if you will. Covalent compounds, sometimes called molecular compounds, we're going to use covalent compounds, are structures which are made up of atoms that are effectively sharing electron configuration as opposed to transferring an electron, say, from sodium to chlorine, making a sodium ion and a chloride ion. A covalent compound actually has electrons overlapping and making what are known as molecular orbitals. We're going to talk a little bit about how to name these types of compounds. It's actually pretty straightforward. And let's start with something that you're already familiar with. We can name and see the structure. If we write the formula CO2, we can see that we have a structure which has one carbon atom for two oxygen atoms. And in this case, you know that the name of this material is carbon dioxide. As such, you can see pretty clearly that the first part of the name refers to the element of the first part on the left-hand side. The second part here refers to how many of the second element there are. And the second element is actually named not as the element, but as the ion. So in discussing the process here, let's go through some general ideas. First of all, we're going to follow this pattern, namely the first part of the structure is named as the element, the second part is named as the ion, but you should recognize something. There is no charge balance here. So there's nothing to say that we need to balance positive ions to negative ions. In fact, you'll see that both of these materials typically are nonmetals. So if we have some material that represents a structure between two nonmetals, in your case, so we might have something such as carbon dioxide, or we could have something like this. We could have SCl2, and again, we'll follow the same pattern. The first part of the structure is named as the atom. In this case, the atom is sulfur. The second part is named with the Greek prefix. In this case, it's di. And of course, the third part is named as the ion of the element, so it'll be dichloride. So this is simply sulfur dichloride. Then you can see how this process works without too much difficulty. We can extend this a little further and take another example. We might have something like this. We might have something like Cl2O7. In this case, we want to use the same pattern in naming. So the first element here is chlorine. We're going to name it as the element, but we have two of them, so we have to say that. Somehow we have to express that, and we do that by using the Greek prefix. So we say this would be dichlorine, and here we have a 7, which is hepta, and we would name this as the oxide, so we'd say hept oxide, because typically we engage a situation here where we have, and it would be hepta and oxide, so we drop one of the vowels, the A, on the hepta. So we have dichlorine heptoxide. And this is the general procedure for all these nomenclatures that you have, which are covalent compounds. Now, there are some common exceptions that I think you should be clear about. Everyone calls this water, not dihydrogen oxide, for example. So that's a common scenario. There are other examples, but if you recall some of the binary acids that we were making before, if we made this material And we did not put it in water. We left it as a gas, which is what it exists as. Then this one would be named in the same pattern we've used above. The first part is hydrogen, right? Hydrogen, and then chloride. So this would be hydrogen chloride gas. So the process is the same, the pattern is the same. We can use another example of the type we had earlier. For example, we can have H2S as a gas. This would be named as dihydrogen sulfide. And by the way, it's commonly known as hydrogen sulfide, so that's a nomenclature. Common use would simply be called hydrogen sulfide. We also have scenarios in which there are some common materials. For example, any of the diatomic molecules. This is simply not dihydrogen, it's simply hydrogen. This is oxygen. So H2, O2, Cl2, N2, F2, and we have Cl2, Br2 when it's a gas, etc. So we have a series of these that are diatomic elements. So we have hydrogen, oxygen, chlorine, fluorine, nitrogen, and of course bromine when it is a gas. The process here is the same for just naming these particular elements as the element. There's some other elements that have names that are covalent. For example, you may have heard of this. This is known as ozone. Some common names that are going to occur, not oxygen, not trioxygen, simply known as ozone. Okay, so going back again to a couple of others, we might go through and take a look at some of these additional ones. For example, here is one. So in this case, this covalent compound would be a form of phosphorus and oxygen. And so how many phosphorus? 2 phosphorus. We have diphosphorus. Okay. And we have oxide, but how many? We have 5, so we would have penta, but again, we draw up the A, so it would be pentoxide, diphosphorus, pentoxide. And that is the general format for naming the compounds that are covalent, sharing electrons, and not forming ions. Okay.